Hello, everyone. I'm here with Mark, and we're going to talk about the Hackers Cup. How are you doing, Mark?
Thanks, Thomas. Thanks for having me. Well, hey, folks, it's a real pleasure to see so many people here. Um, I thought maybe we could start off with like some like a few words about like why this competition is like so interesting to like a lot of the organizing team and why we decided to spend time creating this competition. So Hacker Cup is a very old organization. Like the as a human coding competition, it's been going on for like about like more than 10 years now. And the problems are like really hard. And there's like reliably maybe like a few hundred humans on the planet who can like reliably solve the problems in this competition. And this is and we felt that this is kind of like an important benchmark for AI because like a lot of these problems have like tricks and require like insight and planning and like thinking out of the box or simplifying assumptions, which you don't typically see in the sort of typical coding agent workflow. So for the most part, as far as we're aware, like most of the sort of AI agent community has like focused on like lead code or SWE style problems. So things like editing GitHub code or solving a lead code problem. And the problem with that, as like many programmers can attest, is a lot of those problems are effectively solved by like copy pasting from code from like other developers. And so, like, fundamentally, yes, like LLMs, for example, are going to be fantastic at pattern matching or even like finding or like basically indexing data that's already in its training data. However, like it sort of like really remains to be seen whether these kinds of models can generalize over for competitive coding problems that require like actual planning. So to this end, because the problems are so like darn hard, we split up the competition into two tracks. One is a closed track where you can basically use any model that you want. You can use like ChatGPT, you can have like infinite resources. As long as like your end inferences take on the order of a few minutes, you're pretty much like good to go. And then on the other side, for people, and this is kind of the track we're personally more interested in as organizers, is an open track where you have to fully reproduce the artifacts that allowed you to create your AI agent within less than a day on a single A100 GPU. So basically, you would like train the model, fine tune it, do whatever other post processing you might need to. So yeah, the cool thing about this is that whoever wins this competition would have made meaningful progress towards AGI, would have created a competitive coding bot that's like commercially useful that could be used to deploy and solving like hard algorithmic problems. So I'm excited, and hopefully, you're a bit more excited too after listening to my pitch. And I'm very thankful because like this is hard. Because it's a hard competition, it could be kind of hard to get started as well. And so Tom has like spent a good amount of time like creating a starter kit for us, and will help us like go over some of the more fine-grained details to make to make a submission work.
Thank you, Mark. Yeah, this is exciting. And yeah, you don't realize how hard it is until you start like reading the problems and trying to figure them out. And actually, yeah, the most one-shot solutions are pretty bad or useless. So yeah, there's a big data set, more than 10 years of problems with the solutions and the expected outputs, inputs. So I'm gonna try to today show you a little bit how to navigate the repo and how to get started with a very simple one-shot solution using like a vendor's model. But I'm actually very excited now that you mentioned about this like fine-tuning and fully reproducible track with 1A100. That's a very hard limit actually. But fine tuning should be good enough, and we have enough data maybe to do that. So yeah, you will be limited on the size of the model, but maybe you find tricks to fine tune the biggest possible model on that time limit. So yeah, I have started putting together a repo for you guys. So I'm Thomas. I work at Weights and Biases. We're an experiment tracking company, and we have currently released a new product specifically for tracking your LLM interaction. So I will actually show you a little bit of how we deal with this type of problematics and how you can organize your experimentation on a nice way. So yeah, there's the Hackers Cup AI repo, and there's starter kit sub repo here. Let me share my screen. So everything is on the Discord. I encourage you to join the Discord if you want to participate on this competition. Let me share my entire screen. So yeah, we have a Discord that it's pretty live. Hackers Cup Discord. Mark is there. We have a general channel that has, I think there's like 1,200 people already into this Discord. And
Close to 2,000 now,
yeah,
actually.
oh, close
It's
to
like
1,000 already. Okay, yeah, it was
yeah, it's
1,200 I
awesome.
think on Friday, so it's yeah, it's gonna be increasing. Oh crap! So I will be here trying to assist you guys if you want to like continue working on this or anything I can help you. I think Morgan and more people from our team is already here. Like more is in here, and yeah, we have like questions here. Like please ping me if you need something. So encourage you to join. I know we have already too many Discords, but this is one that probably you need to join if you want to participate on this competition. So yeah, the Hackers Cup AI repo is this one, and it has this starter kits, and yeah, a lot of folks have been working together to put some code to get you started. I started putting files here in the submit for solution, and it's a very simple structure. So basically, we have like three files: one that creates a one-shot solution, one that runs and evals that solution into multiple codes and problems, and then a simpler wrapper O3 point eval solution that lets you like bring your own outputs and just eval them and have like a nice way of tracking your progress if you are not using any of those. Because I read on the Discord that a lot of people have a problem like evaluating on comparing outputs. So let me just open quickly this repo. I have the repo clone here. So I put together a simple small download script that's based on the other download script that's out there. But if you hit that download script, the original one, you will download the full data set that is actually substantially big. So I have like a simpler parsing script that lets you download just a specific year. And for my experiments here, I'm working with only 2023, last year competition that has like solutions, inputs, outputs, everything. So you can use this script, just pass a year, Python download.py year 2023, and we'll download like this dataset folder that will only have 2023. You can then try other years maybe. So if you execute this and you get the 2023 folder, this is the past year competition, and it's formatted per folder. So you have like the practice round, then the 3 rounds, and then the finals. So today I will mostly show you the practice because this is what I have been playing with, and I'm mostly familiar with the problems now. So if you open the folder, you will get like some images because some problems have a description with an image, maybe explaining how you should construct the solution. The good example of this is the cheeseburger corollary. How can you construct cheeseburgers? And they have like a diagram of what you expect a valid cheeseburger is. So yeah, you can open the problem here, the markdown description. Yeah, we can render that here. Oh no, that's the solution, sorry. Where's the input here? It's that one. So we can probably open that. Where's that? That one. And we can render that here. So yeah, you have an explanation of the actual problem you need to solve. You can actually read this on the pages, on the Hacker Cup's webpage. I think I have it here. Hacker Cup. I think it's on the README you posted here. Let me open Mark's link here quickly. I think it's this one. And yeah, if you go to official rules, no, that's
Yeah, so as far as like the official the rules, they do require, unfortunately, like
yeah,
a
you need to
Facebook
log.
login.
No, but I'm trying to just open
Yeah.
this.
Oh, yeah,
That's
then
what I
this
was
is
trying to do.
great.
Yeah, this is last
Yeah,
year competition. So this is like the human competition.
yeah.
So you can see
And by the
like,
way, to people, this is how you register as well. Like
yeah.
basically, just go to 2024, and if you click there, you can register for any of the rounds.
Yeah, so I'm just trying to show you that like the files I'm looking on the terminal here are the same you get from the past year competition. So if you are just a human and not an AI and you can read web pages, you probably go here and see, okay, yeah, there's an image explaining what's happening here. So yeah, we have to construct valid burgers from a set of like buns and burgers, and how the input file is described, what are the constraints on the different variables, and sample input file and the sample output file. So this input file should generate that output file. So the code you need to produce should be capable of taking any sample file and producing any output. Actually, to submit your solution, you will need to run your code against the full input file that is way longer than this like sample input. So if we go back to the terminal or to the project here, yeah, for one problem like corollary ch1, you have like multiple files. So as you can see, these are like the samples. So the same sample we were looking on the web page here, that one, it's also there, and the sample output that's here, it's also there. Okay, so also you have a solution for this problem is in C++, and you have it here, you can run it, and it should produce for the input the correct output. So if you are training a model, probably you need to use those high quality solutions to put that on your data set to actually your model is capable of generating this like smart. As you said, like these are not out of the box solutions, so probably you need to teach the model to construct these type of solutions. So
So
yeah,
speaking of, so actually, if you go back to that to the code file, the C++ one.
oh, um,
So another thing to keep in mind with a lot of these problems is please try to have a good baseline. And for example, in this case, you'll notice that the answers are either yes or no. So the baseline is basically a coin flip. And at least my observation with these models was I could get a model spit out this like very beautiful looking algorithm that did less than a coin flip, but I was still fooled into thinking there was something crazy going on because it was explaining its reasoning with chain of thought, and I'm like, wow, this is AGI. And then, one of my colleagues reminded me that this is worse than a coin flip. So, so beware of those biases, I think, as you're
oh, yeah, that's a good
working with
take.
these
Like we
models.
should probably run like an eval on CoinFlip and see if our model beats that. Yeah. This specific problem, yeah, it has like input outputs in this format that are yes or no. So if the input is capable of generating a valid burger with these inputs. So actually my one-shot solution here, once you have downloaded data, it's using a vendor's model, in this case OpenAI, but you can replace with whatever model you want. And it's actually pretty simple, and it's not very good. It's actually bad. But it generates a valid output, and you can actually run that code afterwards. So at least for this track, I think it's necessary to generate code. So generate the actual script that's going to run and is capable of ingesting like an input file and producing an output file. And then evaluating that solution, like the code, and maybe compute some metrics on the output because, this, as you said, is like a coin flip, but it could be correct on some lines and incorrect in others. Like it has multiple inputs and multiple outputs. So yeah, we will come out with a metric for that at least. Maybe I'm biased by maybe you can suggest something fancier, but at least that's how I feel like I was getting started. So the first thing I noticed is that I first download the full data set and not all the problems are formatted correct equally. So 2023 data, I think 2022 is the same format, but 2021 is another format. So I need to like change my parser to be able to read a 2021 problem with my. So that's why I stick to 2023. So I was like, okay, I don't want to spend time checking name formats and whatever. So you may need to do that if you want to like read multiple years. So as you can see, like we need to parse all these files, like all these channel one files. So my solution to this is creating like a small data class that holds every single file that relates to the problem. And you can get started. It's like I have this mini lib that's just like a place to put the files. So problem.py has this class that has like the name of the problem, a description if there is one, the sample input and output files part already, like the actual content of the files, The input and output path, I'm just storing the path because these files sometimes are huge. Like for some problems, these files exceed the 100 megabytes, so multi-million line files. So also beware with your Pythonic powers that could kill your script. The folder path, if this thing lives on a folder, if there is code, I may want to store that. For this specific example, I don't need the code. I'm going to generate the code. And images, it may be optional, but some of these models actually perform better if you pass the images. Like at least I'm using GPT-4 here. You can send images to GPT-4o. And so, yeah, you need to parse them specifically, but the code to parse the images is actually here. And I think all the models that support images use the same like base 64 encoding. So
Yeah. So,
there
so,
is
so,
that.
so, so a few thoughts here. Like the first one is like images are actually not necessary to understand the problem. However, humans find the images extremely useful. And so you can just like not parse the images if you want to, but you know, it's sort of like highly recommended you try them out because the diagrams like have a lot of care because they do try to explain like a big chunk
Yeah.
of mathematical text very succinctly. So regarding the input and output paths, by the way, this is very similar to, you know, when you try to solve a leak code problem and it like runs like a few tests. Just for context, like as far as humans go, if you fail any test, it means you didn't get the problem right. However, if we did this for the LLM tracks, for the AI tracks, like it's very possible almost everyone would get zero. And so we are indeed allowing for partial credit. So the more
Oh,
test cases you've solved, the better. But you should know between like basically as you're working on this that like partial credit is sort of not it's not that mean it doesn't mean your model got the trick, right?
okay.
You should really aim for 100% solve rate.
Okay. Yeah, it makes sense. Um, yeah, so there's a lot of like boilerplate here, like reading from a name, from folder, from find all to find all the problems on a folder. Um, and then like in the one-shot solution, what we're going to do is basically read one problem and like create a prompt that's capable of explaining the problem to the AI, in this case GPT-4, and trying to make GPT-4 generate a code that we can run to produce an output. And then that's the output you would submit to the competition. Of course, this is like one shot in the sense that it's just one pass. It's actually two passes, but it's, yeah, you should probably do something way fancier than that. And I will talk about low hanging fruit to improve this, and then maybe someone will find a better way. So this is no dependencies besides like OpenAI and like some simple parsing. And I'm using our tool called Weave that helps you like track the inputs and outputs, but there's no dependencies more than that. Um, so yeah, call mall is just calling GPT-4, and then we're gonna like, how do you say, Chuck Norris here trying to get generate code at once, and yeah, that's not gonna probably not gonna work that well. But yeah, it's just calling them all with a list of messages. So we have like a system prompt. Yeah, you may tweak that, and a prompt template that expects yeah the problem description. We need to tell them all what he's trying to solve, and and we're gonna give the sample input and output because that's what you get on the front page. So let's give that. And we're gonna pass the images optionally, like there's a flag, pass images or not. And this should get you like an output that's close to a working code. So we just do that. We call them all with that list of messages that will get like our initial analysis. Some of these models are very verbose and will not give you just the code. Will give you a lot of explanation of like, hey, yeah, I see you were trying to do this. Um, yeah, we are going to run it and you're going to see. So we need to call them all again, at least to extract like and get a functional piece of code. Because sometimes like it will put pieces of code, text, pieces of code. So it's not just like a regex and get the code. So we're gonna ask them all like, hey, give me an executable code. And I like progress bars, so I will ask him like, hey, put a progress bar because I found that some of the problems like run very long time. So this is the actual prompt I'm using. It's very simple. You are an expert problem solver. Your task is creating the code to solve the problem in hand in Python. And then the template I'm giving is the problem with the description, the sample input, sample output. And I'm asking to create a Python program that gives the correct output and input. And then I'm just asking, hey, can you put that on the top, like import TQDM? And I'm passing actually the header of the function. So I want a function that's called solve and just take the input as a string, like super simple. Because sometimes it'll give you like, it expects a path, or sometimes it will expect like, yeah, I want to minimize like what it expects. And I found that this helps like to get more consistency on runnable pieces of code, because like there's two stages. Getting a piece of code that runs, and then like getting a piece of code that runs and generates a valid output. Like first stage is getting some, so I'm measuring actually if they run, and then if they run, then I verify that the output is correct, at least on the sample. So the actual function is like solve problem. So you generate a piece of code, you get the inputs and outputs, and then like you run that code against the input. So you get the generated output, and that's the output of my like solve problem function. So we are actually returning everything because we're gonna be able like to inspect every piece. And then in the main part of the code, like we're gonna solve the problem. We call check solution. I have a handy function I will show you that checks the solution. And then we're gonna print and debug everything. Actually, I encourage people to not naively run on the actual input. Like if we go here on the data set 2023, you have like an in file. That's the actual input for the problem that you need to submit. But there's also like sample input. I encourage people running everything on sample input first, debugging all their pipeline before trying to attempt to run on input, because these files sometimes are huge, and yeah, it's just gonna like slow you down. Like until you are ready to pass to the input files, just run on sample. So as you can see here, like two stages. First, solving on sample input, and then solving on full input. And this problem is actually pretty easy. I'm running by default on Cheeseburger Corollary 1, and that one almost of the time works. So if I run this, why? Okay. So if I run this, and you get you get the prints and statements that are over the place, the logging info here. So yeah, it's trying to generate a code for the solution, generate initial analysis and solution. That's because like it's retrieving the piece of code, and then it's running the solution on the both pieces. So this is like the sample that has only 7 cases, 7 are correct, no offending cases, and this is running on the full output, and 79 cases are correct, no offending cases. This is a really easy problem. It's so you should be able to run this against any of the 2023 formatted problems. So you just need to change like the problem name. So yeah, you should pass problem name here and pass another name of problem. So I'm just gonna show you that I instrumented this with our tool just to show you why. Because when they fail, yeah, debugging this is, I like to have some telemetry at least, because this pipeline is trivial. It's like one LLM call, but if you are going agentic and like maybe calling multiple times, running, checking outputs, calling again, you need to be able like to inspect what happened between, because sometimes like the parse output is wrong, or maybe you expected JSON format and you didn't get that. So yeah, you get a trace of what happened here. So on the UI, what it happened, this is free, like you can register to W&B Weave, and you get the check solution input output, and you get the different traces of what happened during this call. So we call solve problem, and solve problem generated code, that call OpenAI, and that call OpenAI again. So we can see that this is for extracting, so extract the code, the response, and omit an additional. So this is my last call to actually extract this function, and we can see that we got the function extracted correctly, and look at that, it used TQDM. That's great. So yeah, so this kind of telemetry is really important, I feel, for when you are like trying to complexify your pipelines. So I haven't shown you that I have a check solution function here. Check solution is basically just comparing this line by line, and if one line fails, I will assume it's one of the cases, and you will get that into the offending cases. So maybe you can check, or maybe you can re-inject that into the model, like, hey, you failed that line, maybe create more samples so I can check. I don't know. I think there's multiple paths to improve this. So this is like the getting started path. As I show you, probably this easiest low hanging fruit here is like after extracting the code, maybe run it on the sample, check if the output is correct, and then like re-inject into the prompt and re-ask them all to generate a better solution if it fails, instead of just like ninja dropping the code that you just generated firsthand. But like that's one kind of agentic, super simple step to do. I don't know. There's multiple ways. Maybe asking them all to generate 5 possible solutions. Maybe asking them all to generate like a more efficient script. So like a post-processing phase where you ask, hey, check this script. Or maybe a parallel call to them all like, hey, check that script. What does this script do? And maybe explain, and then like compare that to the actual explanation it gives you. So I'm curious, Mark, about you said that there's like a time limit of how long this should run. And how do you handle, like, I could make hundreds of parallel calls to an API. Like
Indeed.
that's allowed.
Yeah. So for the close track specifically, if you're calling a model like OpenAI, because you can make asynchronous requests, you can do things that humans can't do, which is like generate like hundreds of samples like in parallel and solve all problems concurrently. Concretely too, like when you get the like as an AI, like you're gonna basically come to the problems, and there's gonna be like a download tarball button, which will have like all the files. You'll unzip it, and then you just pass this like you basically pass like all the problems to parallel models, and then they go. And that's why for the close track, we just have like a hard limit of 6 minutes for all problems in all the rounds. Basically, the whole thing needs to finish really fast. And the intent here is to basically really ensure that it wasn't possible for a smart human to be in the loop and solve the problems, because that is actually the easiest way to cheat, by the way. The easiest way
Yeah.
to cheat is you just get like a very strong human to solve the problems really quickly.
Okay.
So the time limit prevents this. But however, for the open track, which is like when you're like fine tuning, we're a bit more lenient there because we're gonna have the chance to reproduce people's artifacts in the end. So if people did indeed cheat, it becomes very apparent very quickly if they did. And of course, like we don't want to turn this into like a write efficient CUDA kernel competition so that you can get the inferences working fast enough. And for an open track, it's not necessarily easy to scale the number of inferences because you need to add more GPUs, which just doesn't make sense for most people doing these fine tunes at home. Yeah.
How do you feel about like the the closed models, maybe open also? Like, this is public data. I'm pretty like I asked OpenAI and asked Claude, like, do you know the Hackers Cup competition? And they know, like, oh yeah, blah 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 blah. Like, yeah,
Yeah,
probably it's
so
already on the training data.
it's a great question. Yes, indeed. All historical Hacker Cup problems are probably in the training data, but 2024 is not.
No, of course,
And
yeah,
so, because like when the problem gets released, it's going to be the first time both humans and AI see it at the same time. So it's like a real eval. And so it's not necessarily about like not worrying about contamination. Like at this point, like we feel like the only real solution to deal with contamination is just not make data sets available on the internet until like the last minute. So that's kind of our mitigation for that.
okay. So you have 6 minutes to run all the problems from all the different folders. Like in this case, it would be, yeah, you have to submit all of them in 6 minutes.
That's right. Yeah.
Not
This
only
is especially for the
finals.
cluster. Um, yeah. So basically, like as many of the rounds humans are doing, like you're doing just as many all at once. So like
Yeah,
there's like
but the
really, yeah,
competition will be opening like practice round first, and then round one, then round two.
correct.
So
Yeah.
like,
So basically, you have to relog in at different dates, and those dates are listed on the website. And
okay,
you basically would do each round. There is an elimination aspect to this competition. Like basically, like our theory right now, and Weiwei and I have been wagering about this, is like when do we feel that it's very likely that AIs will get all zero, like on everything? And so far, people think round one, others think round two. And so basically, people are welcome to participate in as many rounds as they want, but they'll only be on the leaderboard if they qualified in every single round.
Okay, that's cool. Oh, we're gonna give it a spin then. Um, yeah, so this is my like one-shot solution as I was showing you. Like this is far from what you expect for actually submitting a full solution for a round. But yeah, it takes at least this is like two OpenAI calls. It takes like yeah, around like 30 seconds in total to generate one solution. So if we call like OpenAI at least one per problem, you will be under 1 minute to submit like a full solution for this for the 2023. Actually, the run and eval, the O2 file run and eval does that. Like it tries to solve all the problems at the same time. The prompt is slightly different because I need to run them in parallel, and you can try it on your side. It has some like code that will be evolving. I will probably be refactoring this during the week to make it shorter because yeah, I had to do some shenanigans of like spinning a new Python agent to actually run the code and running everything async and multi. So Python multiprocessing is always kind of tricky. And then like you get like as I can run it just to get an idea. When you run this, yeah, it generates like it calls 5 times because I'm generating five. I'm limiting it to 5 just to show you here, but you could run the full folder. And it's just limiting always by default to the samples. As I told you before, try it on the samples before running on the full evaluation. And and you will get like a scoring of the final problems here. And I also have put together, let's wait for that to finish. I have put together a even simpler script called eval solution. So it's like bring your own solution. So if you bring, you have another library or whatever you're using to generate this output files, you can quickly evaluate them with my small check solution function that I think it's time to show you. It's a very simple, like just checking by lines that the actual script output matches. And it's computing like an average score, like if all matches and just showing you the offending cases, because you may want to reinject that into the AI if you want to generate a like valid functioning solution. So that's like my approach to actually, this is not finishing. So let me open a new terminal here. So yeah, submit. If you run the O3 file, it will generate an eval on the file you parse. So if you have a result.json that you can construct on your side with the actual outputs and the actual generated, so this is like generated outputs against ground truth outputs, just on a simple JSON file, it will run those against the check solution and it will give you the offending cases. And this gets also tracked, so you can then like iterate and have like a kind of a central repository where you can have your evaluations here. So if you click here on evaluations, that's the function I just ran. So you can see like samples side by side. So yeah, true fraction 20%. Yeah, only 1 out of 5 was correct. And you can inspect like the samples specifically and check the offending cases, maybe get something out of that. I feel this is useful if you want to like have your own pipeline and you just want to check, okay, I'm going to run 2023, post that. Maybe we can put this into a public project so people can like share the insights without sharing any code. Because yeah, this is a competition. You don't want to like share your super fancy techniques or agentic solutions, but you want to be able to actually see if you are improving on the leaderboard. I think, what do you say? Like 2023 seems like a good benchmark, a good proxy maybe for 2024.
Yeah, I will say the problems got significantly harder as far as I can tell over the years. Like there's just more problems and they're longer. And I think it's sort of a virtue of, it's like the same people winning, right? And so they need, it's kind of like online sports, like the meta needs to sort of change and the problems need to get harder. So indeed, like I think if starting from 2023 and moving sort of back in time is probably like the right way to approach this.
Yeah, I'm gonna check if we have some questions from the audience. I'm gonna default to the Discord. I don't know if or yeah, I think we have a chat here because I think we're streaming to multiple sources. So um, yeah, I don't know if we get the questions here. Pipe. No, I don't think we get the questions here. And the Discord doesn't seem to. If you want to pose your questions in the general, I will be happy to answer them. In case you don't know the Discord, maybe we should share that.
Yeah, like it seems like there's some questions coming in from YouTube. I see. It was just like a question on when the first session starts. Like the first session starts on September 20th. That's like when the first practice round starts. So if you're interested, like make sure you sort of register and have your starter kits like ready before that. This lecture series will end basically around like end of this month. That way you get like basically about another 20 days before the practice round, which where the score doesn't count. And then there's like another like week or two before the first round starts.
Yeah. Yeah, so I feel like, yeah, give it a try. I feel probably this is not the way to win. With such a simple solution, you will probably need way more than that. And yeah, we cannot put human in the loop. So yeah, good luck on finding a strategy that makes you generate something that's capable of solving these hard problems. Um, are you participating, Mark?
Um, I don't know. Like, I mean, it's not. No, actually, I think I cannot. Like, basically, the rules don't allow
Oh,
for me to
okay.
participate or to win.
Yeah.
Um, Nothing is stopping me, from posting on Discord though. So like, and some of these problems did break my brain a bit. Like, I tried solving them as a human. I really struggled, and I tried solving them with AI, and I also struggled. So let's see. Like, both were hard.
Yeah. No, I agree completely. Yeah, I don't know. I think another beware, it's like, yeah, some of the files are really big. And I struggle myself with my Python solutions were like taking really long to solve. And yeah, I think Wei Wei was telling me that, yeah, they're probably wrong because they shouldn't take that long. Um, do you know
So
something about
so
like the order of execution, like how long a solution should take to solve the problem? Because if we I would ideally prompt the LLM to create Python code to solve instead of like C++ as the code that is submitted like as valid solution here. Because I'm like
yeah,
worried.
so keep in mind that like you can submit any programming language you want. Like, and obviously the most popular choices tend to be C++ and Python. So you could change your pipelines to run C++ to make them run faster. However, like I think Weiwei is correct in that like this might just give you sort of incremental like speed ups. And if the thing is just painfully slow, like odds are you just didn't find an efficient solution. Like the dim sum problem is kind of interesting because so that's like the problem, for example, like we listed out in the paper. The actual solution is basically like two lines of code, and it's just like a function that you evaluate, like which is like is one value bigger than the other? Yeah, like this is the solution.
Yeah,
Like this is crazy, right? And typically, like like I haven't seen an LLM write this kind of code. Like typically, they'll write an algorithm that looks like very complicated and it looks very fancy and sensible. But yeah, like basically, this is kind of like the benefit of running multiple solutions in parallel, especially for the close track. But keep in mind, by the way, that like if your sampling strategy is like very sophisticated and like let's say you're running like 100 LLMs, like you can't you as a human pick which LLM, well, basically which output to paste in the answer, for the simple reason that we can't really reproduce that when we're trying to declare winners. Like basically to declare winners in the close track, we expect them to give us an API that we can query. And if the API basically doesn't automatically do the sampling and figure out what is the best solution by itself, we will likely, as organizers, not be able to produce results for the closed track. So that's an important nuance to keep in mind is that the closed track is not a human, should not include a human in the loop, except to paste in an answer in the box, and that's it.
okay. Yeah, that's good to know. Like, yeah, okay. I don't know. Do we have more questions coming or I think I cover most of what I wanted to show you guys. I think the next steps will be like I will be
Oh,
updating this with
I do see a question though. So is there a way to run the one-shot file without an OpenAI API key? Like, can I use Llama or Gemini instead of GPT?
Oh, that would be like actually right now it's just using OpenAI, but like you basically need to replace that cold mall with the one you want to use. So it's very modular. Like it doesn't expect anything. Yeah, because like this like message kind of rule system, it's mostly shared now between all the vendors. Um, so and I don't know you guys, but like when I served Llama a couple weeks ago, I was using OpenAI compatible endpoints anyway. So um, I for consistency on your code, maybe it's not a bad idea doing that if you're serving an open mall. So you can like switch between OpenAI and maybe the open mall and check. Maybe use the big mall sometimes and the small mall. Um, so yeah, this could be changed. I think if you use Anthropic, it will be slightly different than this. And and most of the endpoints that serve Llama still abide to this OpenAI kind of schema. Yeah, right now I think yeah, Llama doesn't support images, so this line will be wasted. So yeah, probably use images to false, so you don't send like a base 64 huge token spending on your endpoint. Um,
But so keep in mind, like I think one question that comes up a lot on Discord is like people are confused around which track to participate in, like whether it should be the open or the closed track. So like basically for the closed track, you should think about participating in it if you are using a closed API vendor like OpenAI, like Claude, and you should use the open track if you're actually like mostly if you're thinking about things like fine tuning, like basically you're querying your own data set and you're improving some base model. You can, of course, like you don't have to fine tune. Like you can just have like a Llama endpoint kind of act like ChatGPT as well, and this would be valid for the open track as well. So if you're unsure or if anything is confusing in the rules, just like please let us know on Discord.
yeah, I think that you probably should do both. Like even if you're doing fine tuning, you should probably start by seeing the limits of the base model you think on fine tuning. So maybe implement something like this with an endpoint on the base model you may fine tune. So if you're fine tuning, you with 1A 124 hours, you don't have that much. Um, yeah, you
Yeah,
can fine tune that big.
it's punishing, but like basically here is how I would go about using the 24-hour budget. So basically, like a big part of it is that, like again, this is a specialist model, right? It's like mostly going to be useful to solve hacker cup problems. And so, like one trick you can do is you can aggregate like many sort of interesting and high quality coding data sets like from the internet, and you can basically sample them and diversify them in a way to basically ensure that the fine tuning budget won't take more than 24 hours. And actually, last year at the sort of the prequel for this competition, which was called the NeurIPS LLM efficiency competition that we held last year, that was the main trick all the winners used. Like basically, they hardly changed their training loops. They all just got like very clever with how to sample data, and that turned out to be the trick that mattered the most. And so I would suspect that that's probably also going to be true for the open track this year. Although I am cautious in that I don't want to bias people towards like that solution. I do want to make sure that people really think about like data sets because especially if you produce a very high quality data set for this competition for the open track, we're going to ask that you open source it. You can obviously create this data set yourself. You can like sample it from other existing open data sets. But as long as you open source it by the time the competition concludes and we're good. And if it was indeed used to train the winning model, like that's going to be a data set that a lot of people are going to want to use, and it's going to be like very, very, very valuable for the broader like AI agent community to have such a data set available.
Yeah. Okay, that's really cool. So in the open mall track, everything should run on the A100. Could I use like an endpoint from a vendor to create the data set and then like fine tune the 8B Llama 3.1 to solve the task?
Yeah, so this was actually a controversial thing in the rules last year where we did not allow ChatGPT generated data sets. But like since then, like we've realized that like one, like models like Llama, for example, are like a lot more open with their licenses as far as like generating synthetic data. And if I understand correctly, there's also quite a few popular like open data sets that were like generated with ChatGPT. So this is like not something like we're going to be explicitly enforcing in the rules. Like basically, if you create like a high quality coding data set, that's great, and you should be like allowed to release it.
Okay, perfect. Yeah, because I was thinking maybe I want to use like Llama 405B, interact
Yeah.
a lot with them all, like instead of using ChatGPT here, using Llama. But I will probably want the largest possible reasoning capable model out there to generate those samples and like parse these possible solutions, dump that into a data set, and then fine tune the biggest possible open source model that I can budget into 24-hour A100.
So what's interesting about this is like I recently had someone ask me like, what can I do if I got like 100 GPUs available? And the answer I think I give at this point isn't like train a model. It's like just, spin up as many instances of 405B as you can and just like generate as much synthetic data as you can. So I think synthetic data generation is kind of headed on the way of like, it's basically is going to be like a way for GPUs to pay for themselves, essentially, is my suspicion. And so if even if like you can do this basically, and if you have a lot of GPUs available, but you still want to participate in the open track, this is like one way of doing it. Basically, use your cluster for data for synthetic data generation, but then use a single GPU for your inferences. And this is a totally valid submission for the open
Okay,
track.
perfect. That's probably what
Yeah,
I'm gonna do.
yeah. It's like again, these problems are really hard, and so like we felt as we're drafting the rules that like we should draft them in a way so people can really use whatever is actually the best tool and not just like whatever we allowed essentially. Just because we could have be very stringent and everyone gets zeros, and that's just not a very interesting competition for us to host.
Yeah. No, and as you said, like we had some experience a couple of weeks ago serving Llama 405B for trying to like on a specific use case, and like as soon as we posted that, people started creating synthetic dataset for other things than what we expected. So yeah, as you said, like serving big models and giving access to people and just to generate data is extremely valuable these days. Okay, so yeah, this so anyway, if you're using like the closed or open track, you will need to go through this step of like querying them all and like generating a valid answer. So maybe before like spinning clusters of H100s, yeah, try with a closed vendor model or with one that's served by a partner, and like interact and see the limits, like see how big, how they fail on these hard problems. And the problem we have, I feel that here is that the 2023 data, I kind of feel that they know it. At least ChatGPT kind of know it. So it's biased in the sense that it's giving me sometimes correct answers and it shouldn't.
Yeah, I mean, like this is why like we've also listed like all sorts of like different competitive programming like data sets like on like in our Discord, like we have the link of like dozens and dozens of data sets. There's also this is the kind of thing where also like getting books is quite helpful. So for example, there's books like the Guide to Competitive Programming, which you can check out. So basically, like as you say, like you should really try to challenge these models to uh like by finding harder data for them. And for me, like what was sort of self-evident of this is like when I think about using like LLMs in my day job, um, like LLMs are really amazing if I'm like, let's say, writing a shell script or like a GitHub action, where it's kind of like very repetitive and there's kind of a lot of people online that have posted about those things. They do amazing. But then if I ask it to do anything
Yeah.
with PyTorch code base, it just like spits out like just garbage. And there, like, I hope we can find a good solution for this. Because keep in mind, like, basically, some people might say it's RAG. Great, you can use a RAG. As a chain of thought, yes, use that as well. Synthetic data, like, yes. Like, like your solution doesn't even have to be an LLM. It could just be like a traditional, like, more like agent-like framework with like rules and things like that. Like, just a more algorithmic thing.
Yeah, I feel that,
So
yeah, people sometimes like forget that most of the code is not calling the LLMs, like parsing the output, pre-processing, injecting, executing some code. Like there's a lot of code in general just around. Um, yeah, you will see like if you go to my utils file, like I have a bunch of like remove backticks with regular expressions to actually, when the model still verbose outputs like, here, this is the background code. No, I just want the code. Um,
So that's a good observation. Like just because like I think the winning solution is not gonna be weights. Like that's just I just don't see that happening. Like it's a system, right? And it's a system where calling like model forward on weights is very helpful. But please don't view this as like sort of the only answer, and please don't view it as sort of the hammer by which you just like solve all problems. Like this really needs like sort of this code around it. So that's why like I'm quite thankful. Like the starter kit is quite nice, and I might end up using it myself.
cool. I think we're gonna wrap it for today, and you need to go to sleep.
I did. I'm on 3 hours of sleep, so it's a miracle in here. But like,
Yeah,
thank you so much, Thomas, and
yeah, it
thanks
was
so much
really
for
fun,
doing this.
and I hope people try to play with this and realize how hard it is, because I spent a bunch of time not understanding why it was so hard. Um, thank you, Mark, and I think I need to end it here.
All right. Thanks, Thomas.
See ya.
Hey,
And
thanks so much. Like,
tomorrow we have this again. Are you gonna be there?